We defined physics a few minutes ago as the study of matter and of energy and of the interaction between matter and energy. There are lots of branches of physics, one of which is called kinematics. You did that last year in Science 10 to some degree. Obviously, we'll do it to a much deeper level this year than you did last year, but we're repeating somewhat what you did last year. Kinematics, the first unit that we do, the first realm of physics that we attack here, is defined as the study of motion. You did motion last year, lots of motion, but specifically it's a study of motion without regard to what's causing that motion. In other words, we care about the motion itself. We care about the moving car. We care about the moving bird. We care about the moving planet. But we don't care yet what's causing that motion. What causes the planet to go in a circle, more or less, around the sun? What causes the car to travel down the highway at 108 kilometers per hour? What causes the bird to fly south? Okay? We don't care. All we care about right now in this unit is the motion itself, the speed, the velocity, the displacement, and so on. Now, there's two terms that are pretty fundamental to the study of kinematics, and you've heard these terms before, but we'll review them again. Vector and scalar. Who knows the difference right now between a vector and a scalar before I tell you? Let's go with Lewis. Lewis, you look like you're ready to answer a question there, right? No? Okay, that's fine. Fair enough. That's why we're reviewing it, right? Because not everyone's going to remember it, right? Who thinks they know an answer here? Jared? No? Oh, goodness. Goodness, you guys. How about let's go with Derek? Good. Good. Excellent. It's been a long time since you've done this stuff, right? Listen, when I taught my first year, that was 20 years ago, 19 years ago. When I taught my first time, I went through 5 years of university. 4 years of that university was a physics degree, and then 1 year was an education degree. When I taught for the first time, there was lots of stuff I forgot. Tons of stuff I forgot. It's okay if you don't remember everything from Science 10. That's why we're learning it right now. Okay? Good. A vector has direction, but it doesn't only have direction, it has magnitude as well. Magnitude means size. So for instance, I might travel to Edmonton. I might go at 110 kilometers per hour. Okay, that's the magnitude of the quantity, the 110 kilometers per hour. My direction is north. 110 kilometers per hour would be a scalar because it's only showing magnitude. 110 kilometers per hour to the north would be a vector because it's showing magnitude and direction. Sometimes it doesn't matter what the direction is. A scalar is just fine to describe some things. Sometimes it does matter what the direction is. We need a vector to describe what we're trying to describe. I'm going to define this, and I'm going to show you a little way to remember this, okay, if you don't remember it now. Okay, a vector is a quantity with magnitude and direction. And a scalar is a quantity with just magnitude, period. Now, how do you remember this? Okay, especially for those of you who heard this in Science 10, remembered the terms, but didn't really remember what they were. How are you going to remember this all year? This is pretty important. Okay, all through Physics 20 and all through Physics 30. How are you going to remember this? Well, years ago, it was a lot of years ago. I remember I was grocery shopping with my wife in No Frills. It was called something different then, but where it's now No Frills. I'm not a big fan of grocery shopping. I don't like it at all. So sometimes what I do is I just look at things to amuse myself. Sometimes I just watch people and see some of the strange things that people do. And sometimes I just read labels of products and just whatever, just to entertain myself somehow, because I hate walking around and shopping for groceries. Okay? So I remember this one night I was in the cereal aisle, and I started just oddly reading labels for different cereals. And then I saw Vector cereal, or Vector, they call it a meal replacement, not a cereal, but same thing. And I remember thinking at the time, geez, I wonder what the difference really is. The advertisements on TV were all about how great this stuff is and how different it is than regular cereal, how it can replace a meal. Like it's meal replacement, not just breakfast cereal. I remember thinking, what's the difference? Like, what's the difference between cornflakes and Vector cereal or Vector meal replacement? So I looked at the label. There isn't a whole lot of difference, by the way. There's a few extra things in here that there isn't in a lot of different cereals, but for the most part, it's pretty much nutritionally pretty much the same. But what I noticed that night, and I bought this cereal that night years ago. The expiry date on this, by the way, is November the 13th, 2003. That's how long I've had this box of cereal. Bought it about 12 years ago, expired about 11. I bought it because, not because of the ingredients, but what struck me on the end of the side of the box that wasn't on any other cereal. On the front of the box, it tells you there's 400 grams. That's on every cereal, right? They have to, by law, tell you how much is in the box, right? The magnitude is in Vector cereal. The magnitude you're told about cornflakes or Fruit Loops or whatever. But only on Vector cereal were you given directions for use. Now, I don't know about you. I don't really need directions for how to use cereal. Let me read the directions, by the way. It says, place 55 grams of Vector in a bowl. So place Vector in a bowl, add milk. That's it, by the way. So for those of you who didn't know how to eat this, you put it in a bowl and add milk. What do we do next? Take spoon, eat. No, it doesn't say that. It doesn't give you the next step. Just it says place Vector in a bowl, add milk. This isn't direction in terms of the direction we're talking about with vectors and scalars, right? North, south, east, west, up, down, left, right. It's not a vector per se, but it is a way to remember the difference between between vector and scalar. The only cereal with both magnitude, 400 grams, and direction on the side of the box, even if it's not the right direction that we're talking about, okay, it still says the word direction. The only cereal that says the word direction on it is Vector cereal, right? Okay, don't forget that. Okay, scalar cereal just says how big the box is. Scalar cereal doesn't tell us how to use it. Doesn't give us direction. It doesn't say direction on the side of the box. It just tells us how big it is. So a vector, by the way, if I ask you this question on the quiz, what's the difference between a vector and a scalar? Don't say Vector cereal and cornflakes. Okay? It's not the example. It's the way to remember the difference between a vector and a scalar. Vectors have both magnitude and direction. Scalars have only magnitude, the size of the box. All right? Now, there's three terms that we're going to define today. We're going to tell you something about all three of those terms, including whether they're vectors or scalars. Distance, position, and displacement. Three terms that sound a lot the same. Distance, well, you kind of know what that means, right? Position, displacement, they all kind of sound like they mean the same thing. And they are similar, but they all have slight differences. Distance, anybody want to define distance for me? Pick the easy one. Distance. Jordan, how would you define distance? It doesn't have to be a perfect science definition, just how would you define distance? Yeah, or how far something's moved. Sure, that works. Okay, let's do that. Let's say it's how far something's moved. Or how far something moves. The symbol for it, now usually the symbol is going to be a delta D, a little triangle D, but sometimes you see it just as a little d as well without the triangle. What does that delta mean, by the way, that triangle? Yeah, change, right. So if we're talking about how far something's moved, it's changed. Something about it's changed, right? So usually, again, we see that delta, but sometimes we don't. If you see it written either way, they're both correct. Now, there's lots of units that you can use to measure distance. Lots of them. What do you think the standard unit is for measuring distance? The one that we'll almost always use in physics. Not always, but almost always use in physics. Yep. Jacob, right? Meters. Good. Now, you could use kilometers. You could use centimeters. You could use miles or light years. Okay, light years is a unit of distance. It's a really, really big unit of distance, but still a unit for distance. But usually we're going to use meters. Now, is it a vector or a scalar? Edmonton is 342 kilometers away from Okotoks. Banff is about 200 kilometers away from Okotoks. The space station orbits around 400 kilometers above the Earth. Las Vegas is about 2,400 kilometers from Okotoks. Those are all distances, right? Is distance a vector or a scalar? It's a scalar, yeah. Okay. Sometimes we care about direction, but when we're expressing distance, we don't. Now, if I said Edmonton was 342 kilometers north of Okotoks, then we're not talking about distance anymore. We're talking about a different quantity. That's a vector, but it's not distance. Position. Haley, what do you think position means? Again, it doesn't have to be a perfect science definition. Even though Jordan gave me a really good definition, even though I gave him some leeway on it, he still gave me a really good definition. No pressure or anything, though, Haley. Yeah, perfect. Where something is. Where something is. Now, the symbol for position is real similar to one of the symbols that we can use for distance. It's a D, but it has this little funny half arrow above it. So that's what distinguishes distance from position in terms of the symbol. See this little half arrow. Don't forget that half arrow, by the way. That's important. The units for position would be, well, the standard units at least. Ali? You could use kilometers. Absolutely, you could use kilometers. It's not the standard unit. The standard unit would be meters. Good. Now, is it a vector or is it a scalar? Where something is. Let me tell you a little story. See if we can figure out vector or scalar. Let's say that Daniel is going to the first dance of the year. I'm not sure when that is, or even if we'll have one, but let's say we have one. Daniel's going with his buddies to the first dance of the year. And let's say that, let's pick on Atlanta here. Okay? Daniel's going to the dance with his buddies. Atlanta's going to the dance with her friends. Okay? So they're standing across this crowded room, just like a junior high when all the boys are together and all the girls are together. And Daniel sees Atlanta and he says, I'd like to ask her to dance. Atlanta says to herself, I wish she'd ask me to dance. So Daniel gets up the courage and goes ask Atlanta, says, would you like to dance? Atlanta says, great. Never thought you'd ask. They enjoy each other's company. They dance all night. At the end of the night, Daniel says, you know what? You want to go out sometime? And Atlanta says, sure. Daniel says, you want to go to a movie tomorrow night? Atlanta says, sure, that's great. Daniel says, where do you live? What's your position? At home. And Atlanta says, I live 16 kilometers from Dairy Queen. Daniel says, perfect. I'll pick you up at 7 tomorrow night. So 5 o'clock tomorrow night, Daniel says, wait a second. She lives 16 kilometers from Dairy Queen. That's not very helpful. That could be just about anywhere, right? So he calls her up and says, Atlanta, you gave me a, not a vector, but a scalar. Okay? Has the magnitude, but not the direction. See how sometimes it's not important to have direction? 342 kilometers to Edmonton. Okay? Where does Atlanta live? 16 kilometers west of Dairy Queen or east of Dairy Queen or whatever. Sometimes we need direction. Where something is, the position, the direction matters. Okay, where is it relative to what? 16 kilometers west of Dairy Queen, 16 kilometers north of Dairy Queen, whatever. Position is a vector. You're not really telling me where something is if you don't tell me the direction that it is from something. Okay, so we need direction. It's a vector. Displacement. I'm going to define this one just because of time here. Displacement is the change in position. Aidan lived in Calgary last year. Aidan lives in Okotoks now. His position last year was, let's say, 100 kilometers north of High River. His position this year is, say 30 kilometers north of High River. His displacement, his change in position, would be 70 kilometers to the south. Does that make sense? Where he was, where he is, how much his position has changed by, that's his displacement. The symbol for displacement, well, it's close to position, but it's the change in position. The units are meters, at least the standard units are meters. Vector or scalar? Aidan's displacement was 70 kilometers to the, his displacement was 70 to the south, right? Because you moved to the south, right? It changed. You're north of High River in both cases, but your change is to the south. Regardless, there is a direction, which means it's a vector, right? It's a vector. Notice a little half arrow over top of the D? That tells you that it's a vector. Every time that we see this, we've got a vector. Got it? Make sense? All right, let me give you another couple quick little examples of when direction matters, when it doesn't matter. Okay. Let's say right now my position, let's say to the front of the room here is our reference point. The front of the room is 0. Right now I am 2 meters in front of the room. What's that describe? I'm 2 meters from the front of the room, 2 meters to the north, okay, of the front of the room. What am I describing right there? Is it distance? Is that position? Or is that displacement? Displacement. I am 2 meters to the north of the front. What is it? That's my position. Okay, give me a second here, okay? I'm going to walk 1, 2, 3, 4, 5 more meters to the north. What's that 5 meters describe? That's my displacement, yes. 5 meters to the north is my displacement. What's my distance there, by the way? My distance covered. My displacement was 5 meters to the north. My distance is 5 meters, right? I traveled 5 meters. What's my position now? It was 2, just traveled 5. My position now is 7 meters to the north. Okay, let me give you one more. Okay, start 2 meters, okay? Now I'm going to walk 5 meters forward again. 1, 2, 3, 4, 5. Now I'm going to walk back 3 meters. 1, 2, 3. What's my total displacement? I started 2, I walked 5, I walked 3 back. What's my total displacement? No. I started at 2, I walked 5, I went back 3. I'm 2 meters from where I started. What's my displacement? 2 meters to the north. That make sense? The difference between distance, displacement, position? Okay, we'll wrap it up there today, guys. Tomorrow we'll continue on with some examples that you're going to do yourself for this, okay? That's it. That's it for today.